So those who are not attend also, you can record. So let's look some of those questions. There was look at some of the question which I thought has a little point which you need to understand. Okay, at the center of a large circular ring, a much smaller ring, whatever. So there are two concentric circular ring. One is large, other is placed at the center, and they are in the same plane. So what are things we notice? There are words something like much smaller. And I also noticed when they are placed in the same plane. And larger coil carrying currents I, so it will create a field also. A smaller coil is said to rotate at constant angular velocity omega about an axis through their common diameter. Calculate the EMF. See, most question EMF induced after time t from its start. Many question you should start from the end. So we have to find EMF. Start working backwards. I have to calculate EMF at time t. First of all, what is creating EMF here? Why is this EMF here? EMF is equal to rate of change of flux NBA cos theta. So out of this term, which is varying with time? That's the first thing we need to understand here. So what you understand from here, N is 1, B is a constant because the outer ring is not varying. So the B is not varying. So what is B equal to? B equal to mu naught I by 2R. And can we take this B to be constant through the area of the smaller coil? Since it is mentioned is much smaller, significance of this term is we can assume B to be constant all through the cross-section area of a smaller coil. What is varying here? A is the area of the smaller coil. Okay, so A is equal to pi r square. So what we understand here, only term varying is theta is changing. So that's what, and theta is changing with time. So all I need to do in this question, express theta, initial angle is 0 because they are mentioned, they are in the same plane. So initially, if I write, if this is, suppose this is a coil which is placed, and if this is the direction of B vector, initially area vector also, if it is same or opposite, actually it makes no difference. We are calculating only the magnitude. So area vector, both are initially like this, and it starts rotating. It starts rotating, and if after time t, it will have angular displacement equal to omega t. So this is what it is based on. We have done a similar question. Initial angle is 0. So angle at time t is omega t. So what you can do, since we have to find derivation, we have to find, we can express theta in terms of time. It is varying as so theta is function of time. And we take this derivative, we can easily find an answer. So we'll start from here, step by step, we follow the method, you can easily get an answer. So omega and B, and then we substitute this term here. It will come omega, number of turns of N. In terms of B, substitute mu naught I by 2R. And in terms of A, we substitute pi small square A. And this will come to cos of omega t. Sorry, it will become sine of omega t. So that was the answer. If you do step by step, I think this was a fairly simple question. Anybody has any query in this? Now let's look at the next one. The next question is like this. And figure also is given. So there's a copper rod which mass m slides under gravity on two smooth parallel rails. No friction. So basically smooth indicates there's no friction. Each word has some of the words have special meaning. Separation is L. And so the length of the rod is material. If rod is projecting here, that will not be part of the loop. So what is important? Which length is important? Length between the rail. With separation L, and certain angle theta, and two rails are joined by resistance R. So whenever we use word rails, rails means large cross section and metal. It means that the resistance of this part will be 0. This will have R equal to 0, and this part also 0. So only resistance in the whole loop is R, and which is constant. So as it slides down also, this length will change, but this length has 0 resistance, hence the resistance, overall resistance in this loop will not change. So there is a uniform magnetic field normal to the plane of rail. So this word also important. Which direction in the field is normal to the plane of roll, as in the figure. And we need to find the terminal speed. So we have to start with terminal speed. What does terminal speed imply? We have to find terminal speed. So first, why terminal speed? What does terminal speed imply? Terminal speed always implies net force has to be 0. And net force anyway vertical, that perpendicular to inclined plane, they are anyway 0. There's no acceleration. So net force 0 implies if I take the forces along the inclined plane, if I take a cross-section view like this, along the inclined plane, net forces have to be 0. Along the inclined plane, which are the two forces acting? Forces along the inclined plane is the component of weight mg, and other force is magnetic force. Now, if the magnetic field was vertical, magnetic force also would have been in the horizontal direction. Since the magnetic field is perpendicular to the plane, hence force will act in the plane. So magnetic field will lie in the plane of the rails, and if it is terminal velocity, it has to act in the opposite direction. So what is the component of magnetic field? Fb itself is this itself lies in the inclined plane. So it becomes fairly simple question. Mg sin theta. All I need to do, the direction have to be opposite. In this question, the question is not asking about the direction of current. So we naturally assume the direction of current is such that magnetic force acts up the inclined plane. We just equate those magnitude. And even if we don't remember the formula also, what is Fb? Magnetic force is ILB. What is IL? I is equal to EMF by R. So BLB by R into LB. And we equate it to B is perpendicular plane. So Mg is equal to Fb. We equate this is equal to current into LB. And from here, this will give you terminal velocity. So this also, if you follow terminal velocity concept step by step, this also was, I think, a question which is not. We can move to the next one. Okay. So next question is this. A 100 ohm resistance coil has 100 turns. It is placed in the magnetic field of induction. And moment I see this one, what I notice, this magnetic field is a uniform field. It's not changing with time. It's not changing with space. It is placed in the magnetic field in 0.1 second. Area of the cross section is 1 square meter. Then the induced EMF can't be. Okay. If moment I see this word can't be, this is something where if there's only one answer, 3 answers would have been wrong. But see, moment there's a can't be term here, what does it imply? It clearly implies that can't be term implies answer is not unique, it falls into a range. Okay, then only it is possible. Why it is falling in a range here? Let's see why there's a range. It means that the area cross section 1 square meter. What is this question? In a way, it is simple. What is induced EMF? Induced EMF is equal to change in flux by time. What is change in flux? Initially, it is outside. When it is placed inside the magnetic field, it is not given at what angle this coil is placed with respect to the magnetic field. So since if we talk about is flux is equal to NBA cos theta. Since theta is not given, its value can range from 0 to 90, or cos theta can range from -1 to 1. We are only concerned with magnitude, so cos theta can vary from 0 to 1. So flux also will vary from 0 to NBA, final value of flux. So that's why there's a range. Range is coming because angle is not given. Our angle range is from 0 to 90, or cos theta is from 0 to 1. So what is change in flux? Change in flux is changing from 0 to NBA, and NBA can be changing to NBA, sorry, changing plus is equal to NBA cos theta, and cos theta can be, so it's change in flux can be from 0 to NBA. It is NBA when cos theta is equal to 1. That's change in flux. That's a range. So what is EMF? EMF is NBA by delta theta. Hence range also, NBA can be 0 to, see this value change in flux is from 0 to NBA. Hence maximum value is NBA by delta theta. When we substitute NBA value divided by delta theta, it comes to it comes to 0.5 volts. It means induced EMF can be anything between 0 to 0.5. Is this possible? Yes, it is possible when the cos theta is 1. And these are smaller angles. This also is possible, this also possible. But this value is not possible. Okay, all are within the range. Range is 0 to 0.5. Yes, Alad?
Sir, here if they give a negative value, can we choose that?
See, in this case, most cases, then you have to give orientation. We have to define what is positive, what is negative. All such questions you notice, it is based on magnitude. And by now you would have noticed this is fairly common. Unless orientation of the loop is given, direction of field is given, unless the question is specific about the direction, you understand the question is not about direction. Question is only direction is irrelevant. Okay, this also is okay. You can look at this question. May be simple, and if you think of it, it may become a little difficult also. Current is flowing into axial coils in the same direction. So direction also is given. Okay, on gradually increasing the distance between the two. So what happens? There are two coils, the coaxial coils, and if what happens if we increase the distance, what will happen to current? Okay, so when I think of it, I can very simply answer based on my understanding of Lenz's law. What does Lenz's law say? If I increase the distance, flux will decrease. So my question is pretty simple. If flux decreases, what should be the change in current so that it opposes the decrease in flux? So it will oppose the decrease in flux by trying to increase it. How would current change so that flux increases? The magnitude of current has to increase. It's as simple as that. So how will current oppose the decrease? In terms of by increasing. If the currents increase, so in a way, it compensates, tries to compensate for decrease in flux due to increase in distance. And what if some of you might think it is given both are in the same direction? Try to solve what if the currents were in the opposite direction. Will the answer be any different? Even if the currents are in the opposite direction, what will happen? Try and think of it. And in that case also answer will come to same. Current has to increase. So some of you try this one step by step. You can try solving this question. Would the answer be different if the initial currents were in the opposite direction? Has anyone tried to solve this question for opposite direction? Also. So here application of this is fairly simple. Okay, next. Question was like this. A simple pendulum with bob of mass m and conducting wire of length L swings under gravity through an angle of theta, the two theta. So theta one side and theta other side. It swings like this. So Earth's magnetic field component is in the direction perpendicular to swing is B. So it doesn't matter. Again, here the direction of field is not given, and which is not relevant. It could be because they're asking these questions are only related to magnitude. Maximum potential difference induced across pendulum. So again, this question also, we have to start working from here, start with the end. What I need to find, the term used is maximum potential difference. So first I have to think why there's a potential difference and why would potential difference become maximum. Reason of a potential difference is simple. Where's the conductor here? So this, let's look at step one by first thought we should come to my mind. Why should there be any EMF? EMF is due to rotation of a conductor. What is the conductor here? This is a conducting, the string of the pendulum is the conductor. So this wire is the conductor. So pendulum wire is the conductor and it is rotating about which axis? Is rotating about this axis. So I am able to identify, okay, this is question on EMF due to rotation of a conducting rod. And as it rotates, it is not angular as this pendulum moves from here, its angular velocity will keep changing and this velocity also will keep on changing. The second thing, so one thing I have understood, EMF is due to rotation of a conductor, which is wire. And second thing we understand, EMF varies. EMF is a function of omega or velocity. As the omega and velocity change, EMF will change. And when would EMF be maximum? When velocity is maximum. So from that I understand velocity is maximum at the lowest point and omega is maximum at the lowest point. So that's the point I need to find the EMF. All I need to find the maximum velocity here. So either I can solve in terms of omega or maximum velocity. Let me solve in terms of maximum velocity here. Maximum velocity, this is V max and this is 0. So we know in case of pure rotation, it is equal to BLV by 2. Okay, average velocity. And what is V? V is equal to root 2 GH. Because this loss of potential energy is equal to, we have done this so many times. If it falls by height h, starting from rest, velocity here becomes equal to root 2 GH. And h also we have done number of times this kind of thing. What is h here? H is L minus L cos theta. So it becomes 2 GL 1 minus cos theta. Maybe this one equal to 2 sin square theta by 2. And once we substitute 2 square to sin square theta by 2 and substitute it back here, we can easily find our answer. And this term 2 gets cancelled from the denominator and we get that equation. So overall, if you go step by step, this also was not a difficult question. Okay, so 1 minute. Yes, sir. And one way to understand, look at the graph and you can understand. Okay, I think that's where we are having problem. Let's look at the next question. A conducting loop of resistance so and so, and area is given. So resistance is fixed, area is also not changing, placed with its plane at angle of 30 degree. Okay, and with a uniform and time varying magnetic field, and this is magnetic field. Some of you start thinking, I think this is something, this one common problem some of you feel, what do you think this angle is changing? Actually, this angle is not changing. This angle is 30 degree. See, actually, what does this indicate? This indicates the magnetic field is varying with time, not an angle. It's varying as what? It's varying with time as what function? It's varying as a sine function. So different instances have a different value of B, and value of B as is polarity as well as direction is given by this function. But angle is not changing. Angle between, so angle remains, so angle between the loop. So if I draw a loop here, if we can take a loop of any shape, and we can draw something like this also, or you can draw a circular loop. Shape of the loop is immaterial. What is given? Magnetic field makes a conducting loop, makes an angle 30 degree with the uniform time varying magnetic field. What is if it is uniform? What is this one? Uniform means it doesn't change from one point to other. It changes with time. So this is the angle 30 degree. So angle between area vector and the field vector is constant at 60 degree. This is another thing I think some people go wrong. So whenever angle between magnetic field and plane of the loop is given, we are interested in area angle between area vector and the magnetic field, which is complementary angle, so 60 degree. So let's see what we need to find. Again, if I focus on this and work backwards, I'll start with what? Charge passing through the loop between two instances of time. So this is what I need to find. Let me start with what I need to find and work backwards. Why the charge flow? Charge flow is equal to delta Q by R. It only depends on what is the change in flux which has taken place. So let me try and understand why is the flux changing here. So the flux has three parts. It has is B changing, is A changing, or angle changing. What you find here, what you have to understand, I placed an angle theta. This angle doesn't give this angle. This gives you, this is not an angle at all. This only tells you the B is varying as a sine function of time. So what is changing here? Only B is changing. Area and cos theta are not changing. So when you write up delta phi, I am interested in basically what is the initial value of B, which is at time t is equal to 0. And I am interested in other value of B at time t is equal to, what is the magnitude and direction of B? If the polarity also changes, I have to take with sign. So at t is equal to, second thing is 10 milliseconds. So if I substitute value of t is equal to 0, at b at time t is equal to 0 comes equal to 0. And when I substitute 10 milliseconds, this becomes equal to 0.4 into 10 milliseconds becomes pi by 2. So b value at t is equal to 10 milliseconds becomes equal to 0.4. So during this time interval, why is there a change in flux? Change in flux because the b value changes from 0 to 0.4. Then becomes easy. Now let's put this only b is changing. And what is this delta phi? Final value of b minus initial value of b into a into cos 60. And when you substitute, we get your answer. So this also, I hope, is clear enough. So next one. Second, next question was, I think this question, most of you could not get a hang of this question. Consider what is the thin? It's a thin metallic sheet perpendicular to plane of paper, moving with the speed v in a uniform magnetic field B going into the plane of paper. And this all the figures are given. If charge density are sigma 1 and sigma 2, this also is given, are induced on left and right surfaces of the thin film. We need to find what is value of sigma 1 and what is value of sigma 2. First thing what we need to do, we have to visualize how this thin sheet is. It is perpendicular to the plane of paper. We have to visualize this how the sheet is. If you have to get a three-dimensional view, this is what we see from here. This is the observation from here. So what we see from here, this is the direction B in which it is moving. And this side also, this side will have the right surface as if you observe from here. This surface has charge density of sigma 2, and the other surface has charge density is sigma 1. And that's why if there are, it is, so what will the field between two surfaces? Field between two surfaces, the formula for surface charge density will apply. So this is how it is moving. And let's understand. So let me again come back here. Why should there be any charge? We understand charge comes because of charge separation because of magnetic force. Okay, so this to solve this question, okay, this field charge will get induced because of magnetic force. If magnetic force is acting like this, what will happen? If the magnetic force is like this, what will happen? It will push positive charges here, and positive charges will develop on this surface and negative charges will come in here. If it is acting in the opposite direction, other way around. Okay, so this is something, though it is similarity with our derivation. In our derivation, we have taken a rod, here it is a sheet. So that's why in case of rod, we cannot calculate what the charge will be. In case of sheet, we can calculate what the charge will be. Let's see how we calculate. It is based on the derivation. The derivation, if we calculate, actually E comes equal to, sorry, I missed the negative sign. E bar comes equal to E, net force has to be 0. The net force has to be 0. E is equal to minus V cross P. So what we'll do here to find direction of E, which direction V cross B is? So V cross B, can we find V cross B direction? V cross B, V is along J cap and B is along minus K cap. So if we take this direction, what does this comes to? V cross B comes equal to minus I cap, and hence E will be along which direction E will be? E will be along I cap direction. So it means field has to be towards right. If this has the direction of field, it means left plate has to have positive charge and right surface. See, from here we calculate FB is in the leftward direction. That's what minus I cap is, and field will be in the opposite direction. This is how. This is FB, and this is E. And if this is E, now we'll calculate, okay, this is positive and this is negative. The first thing what I figured out, sigma 1 should be positive, sigma 2 should be negative. And how do we calculate magnitude? So direction we figured out. In terms of magnitude, if a charge is sigma, if both charges are equal and opposite, the field between this in central area has becomes equal. They have to be equal and opposite. There's no net charge initially. So that is pretty clear. These two charges have to be equal and opposite. So if one is sigma and minus sigma, field becomes sigma by epsilon naught. Magnitude of field has to be equal to VB. They are mutually perpendicular. So pretty clear in terms of magnitude, this is one. And in terms of direction, the direction, this has to be direction of force is towards left and E is towards right. Okay. On positive charge. Both have calculated direction of forces on the positive charge. Okay. So direction of field towards right. And then we can easily solve, and we get the answer directly. What is sigma equal to? Sigma equal to epsilon VB. Okay, another question was a conducting tube of side 10 meter is translating with uniform speed 10 meter per second, a region of uniform magnetic field. Okay, which direction? This magnetic field is along K cap direction. What is the maximum potential difference between 2 points in the cube? Again, the moment we come across maximum, it means the answer will be a range of value. So we need to understand why the maximum value, which factors does it change? So maximum implies range. Moment you see anywhere maximum, it means there's a range here. What would the range depend on? EMF is what? EMF is actually BLB. Okay, BLB all taken in mutual perpendicular components. So what is not given here, it is translating angle between velocity is not given, angle between velocity and magnetic field is not given, and also orientation of cube is not given. So only thing, when would the maximum happen? The maximum value of EMF will come when all three have orientation such that all three are mutually perpendicular. Lastly, what is the maximum value condition? When the largest length dimension, V vector and B vector, all three are mutually perpendicular, that combination will lead to maximum EMF. So when all three are mutually perpendicular. What could be the maximum value of linear dimension? Maximum value of linear dimension, it is cube of side L. So maximum linear dimension of any cube. What is that's the maximum distance between any 2 points in the cube. If cube side is L, maximum distance between any 2 points in the cube is across the body diagonal. And this is equal to, very easily you can calculate, is root 3L. You can calculate right angle triangle. The base is root 2L and this is L. So it will be root 3L. So what is the maximum value of EMF when all three are mutually perpendicular along the body diagonal points? And in that case, L is equal to, we can substitute 10 root 3. So it gives you maximum value. So maximum value comes equal to what? Maximum value I calculate, it comes something like 8.75 something. And what is the minimum value? Can it drop to 0? See, minimum value, if what we know, what makes EMF 0, either all three are collinear, all three are coplanar. Since it's a cube, all three cannot be coplanar. There's always some length dimension which will not be in the same plane. It's not a plane, it's a cube. So other thing, what makes EMF 0? If two vectors are collinear. So if velocity is along this velocity, if this velocity is either in the K cap or minus K cap direction, it doesn't matter which 2 points we choose. It doesn't matter what value of L vector we choose. The EMF induced will be 0. So what it means for V along B or opposite, EMF is 0 for any orientation of L, which implies that whichever 2 points I choose in the cube, if velocity, translation velocity is along K cap or minus K cap, EMF induced between any 2 points is equal to 0. So it gives me the range. Range gives me between 0 to this maximum value. And so a correct answer should be anywhere between the two. So minimum value is not 0. See, minimum value can be 0. So one option was can't be 0. No, it can be 0. So that's how the solution was. And last one, so it was something like this, a conducting rod. So this rod is sliding. And what we need to understand here, when this rod slides here, let's read the question. On the smooth resistance, resistance per length is given, bent at angle theta, 60 degree. This angle is 60 degree or this angle is 30 degree. Okay, this is what is given. A variable force is applied to the rod so that the rod moves with a constant velocity. So what is constant here? V is constant. Okay, function of applied force. So how would F vary as X? The first question comes again, start with the end. Why would force vary? What is force equal to? So first, if I understand what is force equal to, then I can think which parameter is varying. What is force equal to? ILB. And if you substitute is B square L square V by R. Okay, that's value of force. All three are mutually perpendicular. So let's look one by one which term is varying. B term is not varying. What is L here? See, we are talking about current flowing in this loop. So when we talk about L vector, this length is not contributing to EMF. This length is not contributing to EMF. What is the length we have to take here? Both L and R are varying. Let's see what's L. This is the value of L we should take here. For the loop, this is the length which is varying. This is L. So in terms of X, I have to write this L. And the second thing, as it moves along, this length also changes. These two sides, all three sides of the triangle are changing. Since the resistance is, this part also has resistance rho per unit length. This also has resistance rho per unit length. This has no resistance. But since these two lengths changes, resistance also will change. So what is the resistance? If I can write this length also, so I have to write the resistance as a function of X. All I need to do, I need to write L in terms of X. L in terms of X comes equal to, what is L? L is equal to 2x by root 3. When I write this one, what is the resistance? Resistance equal to twice this length into rho. Twice rho into the length here. It becomes equilateral triangle, so twice 2 rho into L. And what is L equal to? I substitute the value of R also as L is 2x by root 3. If I substitute these two values in the equation, I get my value of. Okay. So that's what